Hello everyone, thanks for joining me today. My name is Tom Eckwert and today I would like to present you EvolveDB, which is a tool for model-driven schema evolution in relational databases. EvolveDB uses a model-driven re-engineering approach which consists of three phases. In the first phase, the reverse engineering, we start with a legacy database schema and some data in the database. At first, we're going to reverse engineer this database schema into a model representation of this schema. Then, in a restructuring phase, we're going to change the model representation and receive an edited model version. Afterwards, we're going to compare both model versions, and from the delta between both models, we have a delta and the differences between the two model versions. From the differences between the two model versions, we're going to generate a SQL migration script in a forward engineering task. Afterwards, we are able to transform the legacy database schema and the data in the database into the desired target schema. As an illustrative example, we use this simple database schema consisting of three tables, namely property, street, and crossroads, with some column keys, foreign keys, and some constraints. These are desired modifications we would like to do at our legacy database schema. At first, we're going to add two new columns, namely longitude and latitude, to table crossroad. Then we're going to change the single-valued association between property and street into a multi-valued association by adding a new cross-reference table. Then we are going to reduce the size of the name column from 255 to 40. And at last, we're going to change the column type of date created from timestamp to date. After doing all desired modification, this is the desired target schema. We have the new cross-reference table property street. Then the name column has a reduced size, and we have the two new columns, namely longitude and latitude. Additionally, we have the history table, but I'm going to talk about the history table a little bit later. So now let's start right away. EvolveDB is currently available as an Eclipse feature. Eclipse features extend the Eclipse platform with additional functionalities. I already prepared a modeling Eclipse and EvolveDB is already installed, so we can start right away. At first, we have to create a project. It's just a general project. I'll name it EvolveDB demo, and I have to create a new folder for our models. Now we start the reverse engineering task, and in the reverse engineering task, we would like to reverse engineer the database schema into a model representation of this database schema. EvolveDB could be started from the context menu. Now it presents us a list with all available data sources. It is possible to extend EvolveDB to include different data sources, which means we could possibly add my Oracle database or a SQL server, but we have to provide a specific data source for each database type. Now we would like to use MySQL, so I select the MySQL JDBC data source, and for connecting to our data we need the MySQL JDBC driver. Currently there's no JDBC driver installed, so EvolveDB prompts us with a download page and ask if we want to download or if we want to add the driver manually. Now we can download it automatically from Maven. So I click download. And now we can connect to our database. If we have an existing configuration file with the database information, we could import this configuration file, but we don't have one, so I have to add the connection information manually. At first the host is localhost because we have a locally installed MySQL server. The port is the default port, it's 3306. Username and password. And now we can pre-select a schema, or we can get a list of all available schemas. Right now we want a list, so I have to test the connection. And on the next page, EvolveDB shows us all available schemas from our MySQL database server. We would like to use for this demonstration the MDD model schema, and now I click Finish. Then I have to specify a location, the demo.mdde, and the folder is the models folder, And now I click Finish, and the reverse engineering is performed automatically, and as a result we receive our model with the 3 tables from our database schema. During the restructuring phase, EvolveDB supports 2 different use cases. In the first phase, the reverse engineering phase, we reverse engineer the source database schema into a model representation. We'll have a look at this model representation in a short moment. But at first I would like to talk about the 2 use cases that are possible with EvolveDB. In the first use case, we reverse engineered the source database schema into a model. Now we can manually evolve this model representation and receive as a result a evolved model version. Afterwards we can compare both model versions, and from the data we can generate a SQL migration script in a forward engineering task. With this SQL migration script we are able to transform the legacy database and the corresponding data into the target database schema and transform the data to be conformed to the new database schema. In the second use case, we already have 2 versions of a database on, as for example, a MySQL server, and we can reverse engineer both database schema, the source and the target database schema, and we already have 2 versions, so we don't need to manually evolve one of the 2 database schema. And again, we can compare both model versions and generate a SQL migration script. In this demonstration, we will follow the first approach. So we already created a model representation of our legacy database schema, and now we're going to change this model and receive an evolved model version. Now let's have a look at the generated files or created files during the reverse engineering phase. The demo.mdde file is the model representation of our source database schema. Additionally, EvolveDB created a second version of our model. Now it's still identical with the demo.mdde file. EvolveDB follows a model matching approach. So we always need we have 2 versions of a model, and through model matching and comparison we elaborate the difference between both models, and from difference we later generate a SQL migration script. Therefore we need the second model version because we are following the first use case, which means that we're going to edit the demo.mde file, and later we are able to compare the demo.mde file, the edited model version, with our original model version, the demo.v2.mde file. Now let's have a look at the demo.mde file. The demo.mde file, as mentioned earlier, is the model representation of our source database schema, and our source database schema contains 3 tables, namely crossroad, property, and street. And the tree editor on the left side is for seeing our model elements. And if I click on one of our model elements with a left click, a detail page opens on the right with all attributes of our columns or tables. Editing this model is straightforward. I can just edit elements directly, and elements marked with a little star are mandatory elements. For example, if I delete the name, EvolveDB informs me that I have to set a name for a column because the column name is mandatory. So let's edit it back to name. And I have informations like the type or size of my columns. Additionally, I have constraints and can see all constraints added to this index. Now we can start editing our model version. So now let's start editing our model version. So let's recapitulate the desired modifications. At first we're going to add 2 new columns to the table crossroad. Then we're going to change the single valued association between property and street into a multi-valued association. And then we're going to reduce the size of the name column and change the type of the date created column from timestamp to date. So now let's start the modification. First I'm going to add 2 new columns. First latitude, and set a type bigint. Now you see the size column is not longer visible because bigint has a fixed size, so we cannot set a size, and therefore the column is not visible. If I set another size, for example, long text is a bad example because it has a fixed size too. For example, I said varchar, the size comes visible again. We want to set big int, so and save. If we want to set the column not null, we can select this checkbox, but the column should be nullable, and we don't have a default value either. So now we can copy this column and add the column longitude. Then we're going to reduce the size of the name column from 355 to 40. And then we would like to change the date created from timestamp to date. And the last change is changing the single valued association between property and street to a multi-valued association. Therefore, we need a new cross-reference table. With right click, I open the context menu and I would like to add a new table. The name is table property street. And then we have to add the foreign keys. The street DB ID foreign key can be moved from our property table to the new cross-reference table, and additionally the foreign key becomes a primary foreign key. Next, I have to add the second foreign key, and I name it property DB ID. It's also a primary foreign key. The type is big int. And then we have to select the key column this foreign key references. It's the DB ID from table property. And I have to add a constraint name, and I just call it property underscore ID foreign key, maybe 1 or 12. It's not null, and it shouldn't be auto increment, so and we don't have a default value. So now we have the new cross-reference table. I save the demo MDDE file, and let's validate our model, and let's see if we made any mistakes. So I validate model. No, the validation is successful. So now we added all desired modification. We have an edited model version and can now compare our edited model version with our original model version, and that's a comparison between the two, and that's been done in the next step. As mentioned earlier, EvolveDB uses a model matching approach. In the next step of the restructuring phase, we're going to compare the original model representing our original database schema and our edited model version representing our target database schema. For the comparison process, we use the CDIF framework. So now let's start the comparison. For the comparison, we have to select both model versions, the original model version and our edited model version, and from the context menu we can start the comparison process. At the first page of our comparison wizard, EvolveDB asks us to specify the comparison direction. In our case, the comparison direction is already correct. The demo v2 MDDE model is the original model version, and the demo.mdde model is the edited model version. So let's go on. On the next page, EvolveDB presents us the matching results. In the background, CLift already matched both model versions. Matching means it searches for elements that are actually the same in both models. And now on this screen we see all the correspondence identified at the table level. On the left side we see all matchings. It matched street in both model versions, property in both model, and crossroad. At the right hand side we have all unmatched tables. And unmatched tables are elements that are either new or deleted between both model versions, and the property street table is a new element and therefore it's marked green. So it's a table that was created in the edited model version. On next page, We have the same for columns, so we have new columns in our edited model version. And on the left side we see a comparison marked in blue, which means there is a move or a renaming, and now we can decide if the correspondence is correct, and in our case the correspondence is correct because we moved the StreetDB ID from the original table to the property street table. So next we have the constraints, and there are no renamings or movings at the constraint level, so we can finish by selecting a folder for the comparison result, and the comparison result is also a model, and the name I select demo.symmetric, and I also create a migration model. I will explain the migration model a little bit later, but I already created. Now I click finish. Now let's have a look at the comparison result. As mentioned earlier, we use zlif for the comparison process, and the output from a comparison received is the so-called symmetric difference model. The symmetric difference model represents all changes between both model versions. The symmetric difference references both versions, the original and the edited version, and has the matching result. The matching result was presented to us during the comparison process, and we corrected this this matching result. And each correspondence represents an element pair which is actually the same in both models. For example, the street table is the same in both models, and we have the element matched in model A, the original version, and matched in model B, the target version. Based on these correspondences, zlif used these correspondences to identify all changes between both model versions. Afterwards, these atomic changes between both model versions are grouped into so-called semantic change sets representing the edit operations done between both model versions. In our case, we have 5 edit operations representing our desired modifications we did to the original model version. These edit operations are represented with so-called semantic change sets. Each semantic change set contains one or more atomic changes, and for example, we changed the single-valued association between property and street into a multi-valued association, and the semantic change set representing this change contains of 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 atomic changes. For example, adding the new table and adding a new foreign key, or changing the value for the Boolean attribute primary foreign key from false to true. The symmetric difference model is perfectly suitable for representing changes between two model versions. It contains all operators and presents them to the user. But we're talking about model-driven schema evolution, which means we would like to migrate the schema and the corresponding data. Some operators executed on a database schema could invalidate existing data. Therefore, we classified each operator according to its influence on existing data. Therefore, we already created in the last step a so-called migration model. In the migration model, this classification becomes visible. Each operator is classified into one of 3 categories. The first categories are resolvable operators. For example, the create column operator is an additive operator which does not break the conformance of existing data and could therefore execute it flawlessly. Next, we have breaking and resolvable operators. For example, we changed the single-valued association into a multi-valued association. And during this process, we have to migrate existing data from the old foreign key to the new cross-reference table. I opened the operator, the change operator, from the single-valued association to the multi-valued association in our details view, and we see the changes made to the database schema. We create a new cross-reference table with 2 new columns. Both columns are big int columns, and both columns are not nullable. And now we have so-called resolve options, which are later used to specify what should be done to existing data. And in our case, we would like to migrate the data from the old foreign key to the new foreign key. The migration model allows us to model the additional information for the migration process directly into this model. Another example is the breaking and resolvable operator set column size. We reduce the size column, we reduce the size of the name column from 255 to 40. If the column contains values larger or greater than 40, this migration could result in an error. Therefore, we have some different default migration options or default resolve options in this case. For example, we could specify that the column does not contain any violating data. We could specify that violating race should be deleted or set to null, or we could specify the condition manually. In our case, we would like to set violating rows to null, which means every value larger than 40 is set to null. The third category are breaking and non-resolvable edit operations, for example, moving a column. But in our example, in our demo, we do not have an operator from this category. Now we see a little icon, which means we did not set the operator to resolved. All unresolved operators are later not used for the migration process, but we would like to execute all 5, so we set all 5 operators to resolved. Now we add all necessary information for the migration process, and in the last step we're going to generate a migration script from our so-called migration model. The third phase of our restructuring approach is the forward engineering task. But before we start generating our SQL migration script, I would like to show you one more point I forgot to show you. And let's have a look at the breaking and resolvable change set column type. We changed the type from date created from timestamp to date. And in this operator, we see also the point for resolve options, because some data types are not compatible and we have to decide how existing data should be migrated. But timestamp and date are compatible data types. So in this case, the data migration option or the resolve options are not enabled. So now let's start the forward engineering tasks. At first, we have to validate our model, so we did not make any mistakes. The validation was successful, and now we can generate a SQL migration script. The EvolveDB contains an extension point for adding different generators for migration scripts, because different databases like Oracle or SQL Server or MySQL have different SQL dialects. And in our case, we use the MySQL server, so we use the MySQL script generator. Next, now we have to specify a location for our migration script. Let's name it demo SQL. Finish. And now EvolveDB generated a migration script from our migration model. Let's have a look at the script. The script contains 75 lines of code, and now we're going to migrate our source database schema into our target database schema. The last step in our model-driven schema evolution process is to execute the generated migration script on the source database schema in order to receive the target database schema. During this process, we change the database schema and also migrate the corresponding data. I jump right back into MySQL. I already opened our generated migration script, and now we're going to execute this migration script. Therefore, I duplicated the database schema so we can compare the original and the target database schema later. So now let's execute the migration script. The execution was successful, so now let's have a look at the migrated database schema. The migrated database now contains 2 more tables, a history table and the property street table. Let's talk first about the property street table. The property street table is the new cross-reference table between property and street, because we changed the single valued into a multi-valued association. And in the migration model, we selected to migrate the data. So now we see the data from the old foreign key was migrated to the new cross-reference table successfully. Next, let's have a look at the street table. The street table, we changed the data type from date created from timestamp to date. This was also executed successfully. And we changed the crossroad table and added 2 new attributes, longitude and latitude. And we reduced the size of the name column from 255 to 40. When reducing the size of the name column, we selected as a resolve option in the migration model to replace invalidating values that are larger than 40 or have a length larger than 40 are set to null. And now we see in the crossroad table, one row has null for its name, which means there was a value that length exceeded 40. At the beginning, I already showed you the target database schema, which contained a so-called history table. Whenever EvolveDB overrides values in a table with a resolve option, like in this case, the values is not lost or is not deleted permanently, it is written into a so-called history table. So now let's have a look at the history table. The history table contains the table name, the column, the BID, which is the column which has null for its name, and it saves the value which was previously stored in this column or in this field. So now let's have a look at the value. We see it's a very long name. The name exceeds the length of 40, and therefore it was replaced with null due to the default resolve option. This was a short presentation or demonstration about EvolveDB, which is our solution for the schema evolution problem. As mentioned earlier, the tool is available via our GitHub repository along with some additional documentation like developer and end user documentation. And if you have any further questions, feel free to contact me. My contact data is already also in our GitHub repository. So at this point, thank you for your attention and goodbye.